In this video, we're going to be looking at velocity and reflection of wave. And we know that velocity is equals to frequency times lambda, or velocity is equals to wavelength divided by the period. And this is because the period t is equal to 1 over frequency f, or frequency is equal to 1 over period. So if we substitute this into the first equation, we'll get the second one. Now let's take some example. Example 1. A source of sound produces waves in air of wavelength 1.65 meters. If the speed of sound in air is 330 meters per second, the period of vibration in second is. So we know that v is equals to lambda over t. So let's write the parameters. Lambda is equal to 1.65 meters, and the given speed is equal to 330 meters per second. So let's substitute this into the equation by making t, so we'll have vt is equal to lambda, divide both sides by v, then t is equal to lambda over v. So let's impute the values. Lambda is 1.65 meters and v is 330 meters. So we'll work this out. Our result is going to be equal to 0.005 seconds. So that's the period of the wave. Next, in a sound wave in air, the adjacent refractions and compression are separated by a distance of 17 cm. If the velocity of sound wave is 340 meters per second, determine the frequency. So I'm going to represent this with diagrams where I have closed lines that represent compression, and the open spaces represent refraction. So this is the compression, this is refraction, this is compression, and this is refraction, and so on and so forth. Just take note that the compression are close together while refraction is open. So from the they said if the velocity, we should find the distance between adjacent refraction is 12 cm. So then the distance between two refraction is going to be equal to the wavelength, and that is going to be equal to 2 times 17 centimeter. And that's going to give us 34 centimeters. Then we'll have to divide this by 100 so that we can convert it to meters. So that gives us 0.34 meters. So to determine the frequency, you can also determine the wavelength by using two consecutive compression. So remember that v is equal to f lambda. So if you divide both sides by lambda, f is going to be equal to v over lambda as the wavelength. So imputing the values, f is going to be equal to v is 340 divided by wavelength 3.34, and that is equal to f is equal to 1000 hertz. Next, a sound wave of velocity 350 meters per second is directed towards the surface of water. If the ratio of the wavelength of sound in water to that in air is 425 to 100, calculate the velocity of the wave in water. Now we know that the refractive index of a wave is given as the speed of wave in the first medium divided by the speed of wave in the second medium. So n is equal to f times lambda 1 divided by f times lambda 2. This is because v is equal to f lambda. Now the frequency remains the same, so therefore they cancel out each other. So we can now say that v1 over v2 by combining both equations together is equal to lambda 1 all over lambda 2. But from the equation, the wavelength of sound in water is 425. So that's lambda 2 is equal to 425, and that of in air, which is lambda 1, is going to be equal to 100. So we put all these values into this. V1 is 350 divided by V2, that's speed of sound in water, is equal to lambda 1 is 100 divided by lambda 2, 425. Then we just cross multiply. When we cross multiply, we are going to have 350 times 425 is equal to 100 V2. So V2 is equal to 350 times 425 is 148750 divided by 100. Therefore, V2 is equal to 1487.5 meters per second. Example 4, the velocity of sound wave at 27 degrees centigrade is 360 meters per second. Its velocity at 120 is, so we are going to use the formula V1 over V2 is equal to square root of T1 all over square root of T2. T1 and T2 are the absolute temperature. So we have to convert the temperature from degrees centigrade to Kelvin. So that gives us 273 plus 2727, which is equal to 300 Kelvin. Then T2 is going to be equal to 127 plus 273. So that's going to give us 400 Kelvin. So let's impute all of this into the formula there. So V1 is 360 meters per second divided by V2, the velocity that we are looking for, is equal to, so this, both of them are that, we just join them together. So square root of T1 is 300 divided by 400, that's T2. So when we work this out, we have 360 over V2 is equal to square root of 300 divided by 400. We're going to divide that down. So we have square root of 0.75. Just want to change the color. So working this out, we'll have 360 divided by V2 is equal to, the square root of 0.75 is 0.866. Then cross multiply, we have 360 is equal to 0.866 V2. So divide both sides by 0.8662. So V2 is equal to 360 divided by 0.866. And that is going to be equal to 415.17 meters per second squared. Example 5. The speed of sound in air is 330 meters per second. How far from the center of a storm is an observer who hears a thunderclap 2 seconds after the lightning flash? Neglect the time taken by the light travel to the other. So this question is on echo. Now for an echo, let's say we have a sound source from that point. When it hits the wall, the vertical wall, it reflects back, and the distance between the wall, let the distance between the wall be x, then the distance the wave travels back is also s. So we know that V is going to be equal to 2s all over t. So from here we can say that t is equal to 2s all over v. T is the time taken for the echo, the sound to travel, and the echo. So from the question, t is 2 seconds, so we can just put in the values. Here we are given the speed, so v is equal to 2x divided by t. Now when we cross multiply, we have v 2s is equal to VT. Now divide both sides by 2. S is going to be equal to VT divided by 2. So let's put in the value. V is 330 meters per second times the time, 2 seconds, divided by 2. So that gives us, and 2 cancel out each other, that gives us 330 meters. A man stands 1/3 of the way between the walls and claps his hand. He hears 2 distinct echoes 1 second apart. If the speed of sound is 330 meters per second, the distance between the walls is... So let's assume that the distance between the man and the wall is x. Now, 1/3 of the way between the wall and the man is equal to 1/3 times x, and that is going to be equal to x all over 3. Now let's assume the man is here, then the distance from the man between the first point is x all over 3. So that's x over 3. Then the distance from the man to the other wall is going to be x minus x over 3. So let's make that over 1. Then find the LCM of 1 and 3. The LCM of 1 and 3 is 3. So 3 divided by 1 is 3. 3 times 3 is 3x minus 3 divided by 3 is 1 times x, that's x. So 3x minus x is 2x all over 3. So the distance between the man and the second wall is 2x all over 3. Now from the question, we can now say that the distance between the man, which is s over 3, let's say the time it took the man to hear the echo from the first wall is t, and since the other distance is greater, so the other time will be t minus 1 minus t rather. So for the first one, we have v is equal to 2s all over t. That's the formula to calculate for wavelength, for echo. Now for the first part, just let me change the color of that. For the first part, when the distance is s over 3, we're going to have 330, that's the speed, is equal to 2 times the distance from the man is x all over 3 divided by the time it took the man, which is t, from the diagram of. So we can make this over 1, then cross multiply. On cross multiply, we're going to have 330t is equal to 2 times s is 2x all over 3. Here we make this over 1 again, then cross multiply. So we have 3 times 330, that's 3 into 330t is equal to 2x. Now open the bracket, we have 990t is equal to 2x. Now divide both sides by 2, then x is equal to 495 t. So that's equal to x. So let's call this equation 1. Now let's look at when the distance from the wall from the man is 2s over 3. So when the distance is 2s all over 3 from the other wall, we have v equals to 2x all over t. But here we know that, okay, the speed is still the same and the distance s is 2s all over 3. So the speed is 330 equals 2 times, now s is 2s all over 3 divided by t. Now our time is 1 minus t. That's the time it took the echo to come back, minus t. So then make this over 1, then cross multiply. We'll cross multiply, we'll have 330 into 1 minus t is equal to 2 times 2s is 4s all over 3. So we have 330 minus 330t, that is when you open the bracket. So again, it's equal to 4s all over 3. Again, make this over 1, then cross multiply. When you cross multiply, you're going to have 3 times, that's 990. 3 times 3 is 990 minus 3 times 330 0. There's a 0 there. So that gives us 990t is equal to 4x. Now, that's our equation 2. Now, this is our equation. What we have to do is either we substitute x into this equation, or we make t the subject of the formula, since we are looking for x. So we make t the subject of the formula. So from here, we can say that t is equal to x all over 495. So we are going to substitute s over 495 for t in the second equation. So if we substitute, we have 990 minus 990 into, instead of t now we have x all over 495 is equal to 4s. So we have 990 minus 990 divided by 495 is 2. Then we'll have s left is equal to 4x. Now move 2s to the other side. We have 990 is equal to 6x. Divide both sides by 6. So 6 will cancel out 6. Here we can see that x is equal to 990 divided by 6. And x is equal to 165 meters. A ship traveling towards a cliff received the echo of its whistle after 3.5 seconds. A short while later, it received the echo after 2.5 seconds. If the speed of sound under the frequency is 1.5 meters, how much closer is the ship to the cliff? So let's have the ship. Let's say this is x1 and the wall is on the other side. Now let's assume the distance between the ship is x. Now that's the first position. Then at some distance s2 from the wall, let's call the distance x2. So the distance from that point will be x2. Okay. Now for the first distance, the time is 3.5 seconds. Now we know that s is vt for echo divided by 2. So here our x is s1. So we can say that x1 is equal to vt. V is 250, that's the speed, times the time t1, that's 3.5 seconds, divided by 2. So x1 is equal to 437.5 meters. Now for s2, we use the same formula again, vt. So our speed remains the same, 250 times t, that's 2.5 seconds, divided by 2. So work this out. This is going to give us 312.5 meters. Now, how much closer is it from the ship? It's going to be the distance between x1, the difference between x1 and x2. So we have x1 minus x2 is going to be equal to x1 is 437.5 meters minus s2 is 312.5 meters. So when you subtract this, it's going to give us 125 meters. Okay, a plane sound wave of frequency 85.5 Hz and velocity 342 meters per second is reflected from a vertical wall. At what distance from the wall does the wave have an antinode? Now, if we have a wave, this is a wave that hits an obstacle, a vertical obstacle, then it is reflected back this way. Now, if this is a node, this is an antinode, this point here is a node, this is an antinode, and this point here is also a node. Now, the length of this wave is one full wavelength. It's a full wavelength. Now, from a node to an antinode, from a node to an antinode, the wavelength is half wavelength. The length is half wavelength. Then it therefore means that from a node to an antinode, the wave is going to be what? Half wavelength. So let's see, V is equal to F lambda. We are given F, so we can say that lambda is equal to V divided by what? F. Now V is 342 meters per second divided by 85.5, which is the wavelength. And that's going to give us 1.66 meters. So a quarter wavelength is going to give us an antinode. So that's 1.66 divided by 4. That is equal to 0.42 meters.